Okay, so today we're going to talk about trig ratios. So the first thing we want to talk about is trigonometry, which is a whole field of mathematics, but we're just going to cover a piece of it today. And trigonometry is the study of relationships among the angles and sides of triangles. So really, in a brief sense, what we're doing with trig ratios is we're going to compare the side lengths of two sides of a right triangle. Okay, so let's take a look at just kind of an example triangle to start. And we know it's a right triangle because that's marked for us. And we're going to label our triangle with the vertices with capital letters A, B, and C. And then the sides will label with lowercase letters. Side A will be across from angle A. Side B will be across from angle B. And side C is our hypotenuse across from the right angle C. Okay? So then we want to look at the trig ratios. And there's three trig ratios we're going to talk about. The first one is called sine, S-I-N-E. And if we're looking at the sine of angle A, I'm asking you to look at the leg opposite angle A over the hypotenuse. Okay, so to abbreviate that, we can say sine A, or the sine of angle A. It's not pronounced sin, even though the E is not on it. The sine of angle A is the leg opposite of A, so that would be side A, over the hypotenuse C. Okay, so it's A over little c. Okay, we also have cosine of angle A, which is the leg adjacent to A over the hypotenuse. So an abbreviation, that would look like cosine of angle A. The leg adjacent to A, or next to A, is this B, because it's the leg, not the hypotenuse. So B over the hypotenuse C. So B over C. And our last trig ratio is tangent. So the tangent of angle A would be the leg opposite over the leg adjacent. So if I wanted to abbreviate that, that would be the tangent of A is equal to A over B. Okay? Just like that. So that's a lot of words and kind of getting used to the abbreviations. So let's apply it to an example problem. So we'll call this triangle A, B, C. And I'm going to tell you that this side length is 9, this side length is 15, and we don't know this one yet, so we'll call it little b. So the first thing I really want to do is to find out what this little b is, because if I don't have it, then all my ratios are going to be in terms of variables, and that's not super helpful. So we want to go ahead and find little b. And luckily, we know a really cool theorem which we could use. So go ahead and tell me what theorem we might be able to use. Good, hopefully we said Pythagorean theorem, which is that a squared plus b squared equals c squared. Okay, so if I want to plug in those numbers, let's say a is 9, we don't know b, and c is 15. 9 squared is 81, plus b squared equals 225. I subtract the 81 off both sides, and I get that b squared is equal to 144. So then I can go ahead and take the square root of both sides. We know that the square root of 144 is 12. So this side b we know to be 12. So then I can find the sine of a. And remember we said the sine of a is the leg opposite of it. So opposite of a is 9 over the hypotenuse, which we know is 15. And we can go ahead and simplify that. We know that 9 and 15 are both divisible by 3. When we divide top and bottom by 3, we get 3/5. So the sine of a is 3/5. If I wanted to do the cosine of a, I'm looking at the leg adjacent to a, which would be the 12, over the hypotenuse 15. Again, we can simplify that down. If I divide both top and bottom by 3, and I would get 4/5. And then I can look at the tangent of a, which we know is the side opposite, that 9, over the side adjacent, 12. And if we divide these both by 3, we will get it as 3/4. Okay? So that you get some practice doing this, try these again, same triangle, same measurements, but now we're going to look at finding the sine, cosine, and tangent of angle B. Okay? So try that. So the sine of B is the leg opposite over the hypotenuse, so 12 over 15, which would give us that 4/5. Cosine is the leg adjacent over the hypotenuse, so 9 over 15, which gives us 3/5. And then the tangent of B is the opposite over the adjacent, so 12 over 9, which simplifies to 4 over 3. Okay? So hopefully we have some practice with that a little bit. We will practice more when we come to class. And that's that.